So there's a true story of the King Hero II of Syracuse who was given a crown, and he was wanting to know if it was pure gold or fake. So he commissioned scientist Archimedes to find out. So suppose that Archimedes took this crown and he decided to weigh it in the air, and he found out the weight was 147 newtons, and then he weighed it underwater and found out the weight was 134 newtons. And that makes sense because things weighed underwater are going to weigh less than in air because of the upward buoyant force exerted by the water. But what he wanted to find out was, is the crown likely made of gold or some other material? So, by weighing it in air, what that tells you is that the true gravitational force, or the weight, is equal to 147 newtons. Since the only forces acting on it are the force of the spring scale, the upward force of the spring scale and the downward gravitational force, they have to be equal. So the gravitational force, or the weight, is equal to 147 newtons. So now let's look at what happens when you weigh it under water. I'm going to start with a free body diagram. So I'm going to draw a dot representing the crown. And on that dot, I'm going to draw several forces. We have the upward force of the spring scale, which I'm going to call Ft, just the tension. We have the upward buoyant force, Fb, and the downward force of gravity, the Fg. So when it's being weighed, it is still, so we can start by saying Newton's first law, the sum of the forces in the y direction is equal to 0, which means the upward forces, Ft plus Fb, have to equal the downward force, Fg. And we want to figure out what this buoyant force is equal to, because we know the tension force, that's the reading on the scale, 134 newtons, and we know the gravitational force. So Fb is equal to Fg minus Ft, which is 147 minus 134. So the buoyant force is equal to 13 newtons. But what does that tell you now? Because we know the buoyant force, the formula is the density of the fluid, in this case the water, times the volume of the object times g. So that would tell you the volume of the object, but we want to know what the density of the object is. So that doesn't really help us just yet, but what we can do is we can go back up to this original weighing at the top, and we know the gravitational force is equal to the mass of the object times gravity, times the acceleration of gravity. The mass of the object is equal to the density of the object times the volume of the object times gravity. And now look how similar this is to this. And the fact that this one is equal to the gravitational force, which we know, and this one is equal to the buoyant force, which we know. Since these equations are so similar, we can just take one equation and divide it by the other one. So we'll take the equation for the gravitational force, which is the density of the object times the volume of the object times g is equal to, and the gravitational force we said is 147, and we're going to divide that by the other equation, the density of the fluid times the volume of the object times g, and that's equal to 13. So now you see what cancels out are the volume of the objects and the g's, and we know the density of the fluid since it's water, so we know everything in this equation now except for the density of the object. So the density of the object is equal to 147 over 13 times the density of the fluid. 147 divided by 13 is equal to about 11.3, and then times, and the density of the fluid, water, is just 10 to the third kilograms per meter cubed. And if you look at this result, 11.3 times 10 to the third kilograms per meter cubed, and compare it with this table, you can see that it's pretty much exactly the same as the density for lead. So we can say that the crown is likely made of lead.